Hi, today we're going to look at specific heat capacity and specific latent heat. The specific heat capacity of a substance is the energy required to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. The specific latent heat of a substance is the energy required to change the state of 1 kilogram of a substance without changing its temperature. There are two forms of specific latent heat. Fusion, which describes the energy required to melt 1 kilogram of a substance, and vaporization, the energy required to boil or evaporate 1 kilogram of a substance. It's okay if none of this makes sense right now. We're going to look at an experiment which will make things a lot clearer. For the experiment, we begin by placing an ice cube in a beaker. Then next we set up the following equipment: the ice cube, a thermometer, a beaker, a gauze, a tripod, and a Bunsen burner. Use a stopwatch to keep note of the time, making sure to note down the temperature change at equal intervals. At first, the temperature will rise at a steady pace. As the ice begins to melt, the temperature will remain constant. This happens as the heat energy supplied is used to break up the forces of attraction between the particles. As the ice melts, the forces of attraction between particles weaken. The particles are now free to move around, thus losing the ice cube's shape, to form liquid ice, better known as water. Once the ice is completely melted, the state change is complete. The temperature will continue to rise as heat energy is no longer being used to change the state. However, as the water begins to boil and evaporate, the temperature will remain constant once again. This is for the same reason as before. Energy is being used to overcome the forces of attraction between particles, as the water changes from liquid to gas. And here we've got a graph. Most people hate them, some people like them, but we've all got to learn them. On the x-axis we've got the time, and on the y, the temperature. And just as our experiment showed, we begin by going upwards at a steady pace, a plateau, upwards, and another plateau. The steady increase on the graph represents specific heat capacity, and the plateaus, specific latent heat. Remember how we learned about two types of specific latent heat: fusion and vaporization. The first plateau describes fusion, the change from solid to liquid, and the second vaporization, the change from liquid to gas. Hopefully now you understand the definitions a bit more. To summarize, specific heat capacity describes temperature change. Specific latent heat describes physical change, i.e. state change. Here's another practical you'll have to learn. This is how you calculate specific heat capacity of a substance. Here we have a block, made of the substance you want to find the specific heat capacity of. Around the block we have a conductor. This stops heat being lost to the surroundings. The block has two holes, one for a thermometer, the other for an immersion heater. Here we have a circuit. It's powered by a power supply. We have a voltmeter and an ammeter. Notice how the ammeter is connected in series and the voltmeter in parallel. Begin the experiment by turning on the immersion heater for 10 minutes. Straight after you turn off the heater, the temperature will continue to rise. Note down the highest temperature. A way we can improve this experiment is by coating the bottom of the thermometer in oil. This ensures the thermometer is completely surrounded by hot material, therefore giving a more accurate reading. To find the specific heat capacity, we use these two equations. First, we find the total energy conducted by multiplying the voltage, shown on the voltmeter, by the current, shown on the ammeter, by the time, which is 600 seconds since we did it for 10 minutes. We then divide the energy by the mass of the block multiplied by the change in temperature, so the final temperature minus the initial temperature. Your final value will be the specific heat capacity of the material of the block. The unit for this is joules per kilogram per degree Celsius. I hope this helped. Thanks for watching.